right, now we're going to condense some logs. Okay, and this means to write it as a single log. I know, again, this was in the other video, but it doesn't hurt to see it again. Ultimately here, we've got natural log, natural log. So what we're going to do is we're going to deal with, the first things we've got to deal with are these coefficients. Those are the exponents, so we're going to just move them. So that 2 is going to become an exponent up here. The 1/3 is going to become an exponent right there. So we're going to have the natural log of x squared plus the natural log of x plus 5 to the 1/3 power. Now eventually we are going to switch that 1/3 back to its cube root form, but not right away. Now we're going to deal with this addition. Addition is the multiplication property of logarithms, so we're going to multiply the arguments. So that means we're multiplying this and we're multiplying this. Not actually going to multiply it, we're just going to write them next to each other for the implied multiplication. So the natural log of x squared times x plus 5 to the 1/3 power. At this point, I'm going to switch it to the radical form. So the natural log of x squared times the cube root of x plus 5. That would be your final answer. I would accept either one of these as a final answer. Either one would be fine. Write it as a single log. We're still continuing with this. Okay. Now this time it's a subtraction, so ultimately that's going to turn into division, but I first have to deal with this coefficient. So that coefficient becomes an exponent right here. So we're going to have the log of x minus 3 squared minus the log of x. Now you'll notice on here, and I don't know if we've talked about it or if my other videos did, this log does not have a base written here. That means it's a common log and the base is 10. So if the base is not written, the base is 10. Now we're going to deal with this subtraction by making a division problem. So we're going to have the log, and it's always the first one, divided by the second one. And that would be your final answer. This one gets its own slide all to itself. It's kind of a little big and crazy looking, right? That's all right, we can handle it. Okay. Notice here the base is B, so the base is kind of just along for the ride. First thing we're going to deal with are all of these coefficients. That's the first thing we're going to do. Okay. I'm going to bring that up here. That's going to come up here. All of these coefficients become exponents. Okay. So we're going to have the log base B of x to the 1/4. And we'll probably eventually switch that to its other form. Minus the log base B of 5 squared minus the log base B of y to the 10th. Okay. Now when we expanded one a few minutes ago, we had a minus and a minus. We can kind of factor a -1 out of that. It might make our lives a little easier. So if we factor the -1 out of that, we can have the log base B of x to the 1/4 minus parentheses the log base B of 5 squared plus the log base B of y to the 10th. Okay, that's one way to do it. I did this one beforehand and it was a little crazy. I can show you that one later if you want. So now I'm going to deal with this here. So this log base B of x to the 1/4 is just brought along for the ride, minus the log base B of 5 squared times y to the 10th. Okay, we can definitely change that 5 squared to 25. I'll do that in the next step. So now I've just got, oh, a log base b of this minus a log base b of that. And we're going to make it a division problem. So it's going to be the log base b of x to the 1/4 over, well, 5 squared is 25, y to the 10th. Okay, that would be a perfectly acceptable final answer. In the textbook, it wanted it switched to radical form. So the textbook's answer was the log base b of the 4th root of x over 25 y to the 10th. Okay, I would accept either or this. Now Math Excel would probably want it like this. All right, one of my favorite properties of logarithms is the change of base formula. Okay, with the calculators, you have a natural log and a log button on this graphing calculator. Any scientific calculator has those two buttons. Okay, natural log and common log are the only logs that the calculators will do for you, unless you have the fancy one that will let you change the base, and I don't even remember what kind that is. So the change of base formula, ultimately you can change it either to a log or a natural log and your answer is going to be the same. Okay, so log base b of m, to change it to a common log, it would be the log of m divided by the log of b. To change it to a natural log, it's going to be the natural log of m divided by the natural log of b. Okay, so on this one, if I wanted to evaluate this, the log base 7 of 2506, I'm going to find the log of 2506 divided by the log of 7. Going to grab my handy dandy calculator and I'm going to enter it that way. Except for somebody stole the batteries out of that one. So let me find another handy dandy calculator. That's what happens when I don't do it ahead of time. So the log of 2506 divided by the log of 7, and that is 4.02. Okay, either way you do it. Now I just want to show you something. I hope you can see it. Okay, I had to close the parentheses there on the calculator. Make sure you do that too. Okay, that's using the common log. You can also do this with the natural log. So this next one, let's just use the natural log because we can. It's going to be the natural log of 492 divided by the natural log of 8. Okay, so in the calculator, I'm just going to hit the natural log of 492, and maybe you can see that it opened up parentheses. I got to close those. Divided by the natural log of 8, and we get 2.98. Okay, either way, if we would have done this with a natural log, we would have still got 4.02. If we'd have done this with a common log, we still would have gotten 2.98. So it really doesn't matter which one you choose to change the base for. I know there's a lot of stuff in the background. That's what happens when you don't erase it right away.